Okay. 5.5 is all about right triangle similarity. Make sure as you are doing these and taking notes that you are actually doing the entire problem and taking good notes of them. Right. Geometric mean is a special type of average where you are multiplying the numbers together and then taking the square root. If there's 3 numbers, it's a cube root, etc. So to always do geometric mean, it's typically easiest to actually set up a proportion where the 2 numbers you're looking at are A and B, and then you always just want to use X as those 2 right there. So those are my extremes. My means are my A and B are the 2 numbers that I'm looking at. When I solve that proportion, I cross multiply, which gives me x squared equals AB. To solve that for x, you would take the square root of both of those. For these examples, just find the geometric mean. So the first thing I'd want to do is set up my proportion, where my 10 and my 40 are my means. Cross multiply, I get x squared equals 400. The square root of 400 is 20. So the geometric mean of 10 and 40 is 20. Doing this with 5 and 15, put those into my means. Multiplying 5 by 15, I get 75. The square root of 75. I can simplify to 5 radical 3. If you're not sure on how to simplify radicals, a very quick set of examples. The square root of 20, if I want to simplify that, the fastest way is to try to think of perfect squares, like 1 squared is 1, 2 squared is 4, 3 squared is 9, and then 16, and then 25, etc. that go into 20. So I know that 4 goes into 20, and 20 is actually the same as 4 times 5. So the square root of 4 times the square root of 5. Since the 20 was inside the radical, so are the 4 and 5. The square root of 4 is actually 2, so I have 2 radical 5. Another option would be with your 20, if you can't think of perfect squares, break that into basically like your prime factorization. So 20 is 2, sorry, my pen's messing up, times 10. 10 is 2 times 5. Circle your pairs of 2's, that when those come out, they come out as a 2, as a pair, and the 5 stays in the radical. So I get 2 radical 5. Either way, you still get the same answer. If there's a number out front, that doesn't change what you're doing. You still have your 10 out front, just times whatever you would do here. So instead of the square root of 28, I would change this to the square root of 4 times the square root of 7, because 4 times 7 is 28. The square root of 4 is 2, so I have 2 radical 7. Now that I've simplified my radical, my 2 is outside along with my 10, so I can multiply those to get 20 radical 7. Alright, your similar right triangles, basically when you have a right triangle that's broken into 2 smaller right triangles. So when you're looking at them, you want to first look at the smaller triangle and redraw it, where you have an X and H as the legs and the B as the hypotenuse. You have your medium triangle that has the H and the Y, and the A is the hypotenuse. And then you have your large triangle that has the A and the B, and then the X and the Y as your hypotenuse. Whenever you're doing these, in this case you're solving for X, you want to redraw your triangles. If you are not going to redraw your triangles, you are almost always going to miss the problem. So make sure you are redrawing the triangles. And every time I start with a small triangle, a medium triangle, and a large triangle. Now, I am on a device that makes it hard to make straight lines, but these should look like right triangles, where you have a short leg. I always put my short leg over here, a long leg, and then a hypotenuse. I draw them the exact same way every single time. That way it can match up. So this smaller triangle goes with this guy over here. Looking at him, the shorter leg is the 3, so I want to put a 3 right here. The longer leg is the X, so I want to put the X here. The hypotenuse, I don't know, so I'm not going to put anything there. On your medium-sized triangle, that's this guy right here, CDB. The short leg is the X. The long leg is the 9. I don't know the hypotenuse, so I'm not going to put anything there. And then for the whole big triangle, I don't know the short leg. I don't know the long leg. The hypotenuse is all the way from A to B, so that's 12. When I'm looking at these, I notice that these both involve, the small and the medium triangles, the short leg and the long leg. The only time I used the hypotenuse was for the big triangle. So he's not really very helpful because he doesn't match up to these two. From there, I can set up a proportion. And I've essentially done the long leg over the short leg. Because the long leg of this triangle was x, the short leg was 3. The long leg of this triangle was 9, the short leg was x. From there, you're cross-multiplying and solving. Make sure you're simplifying your radicals. If I ask for a decimal, you can give me a decimal approximation. Another example, the first thing you want to do is draw your small, medium, and large right triangles. And then label each of those. If you need to pause this to draw them, do so. Small triangle has a hypotenuse of x and a short leg of 2. The medium triangle, which is ACD, I don't know the short leg, I don't know the hypotenuse, all I kind of know is this piece right here from A to D, which would be 6 if the whole thing was 8 and that piece was 2. So I'm going to put my long leg is 6. On the big triangle, I have the x and the 8. The 8 is definitely the hypotenuse and the x is the short leg. From there, I have the hypotenuse and the short leg, so I can set up my proportion. I did hypotenuse over short. You could have just as easily done the short leg over the hypotenuse. If you look at the little triangle, the short leg is the 2, the hypotenuse is the x. On the big triangle, the short leg is the x, the hypotenuse is the 8. I'm still cross-multiplying and getting the same thing. Square root of 16, which is 4. Another example, first thing you have to do is redraw those triangles, small, medium, and large. The small triangle has the x and the 12, x being the short leg, 12 being the long leg. The medium triangle has the 12 as the short leg and the 16 as the long leg. And on the big triangle, the only thing I know is the hypotenuse, and it would be x plus 16. I know both of my legs, short and long, so I need to set up a proportion. I did this as long over short. I'm going to cross multiply. I'm going to divide in this case because there was not an x squared, but I'm still getting x equals 9. This is our last example. As with all of these, the first thing you need to do is draw your small triangle, your medium triangle, your big triangle. Make sure you are drawing them every single time. Make sure they're all facing the same way. Again, if you need to pause this, pause this. For your small triangle, the short leg is 36, the hypotenuse is 60. In the medium triangle, I don't know what the short leg is. I don't know what the long leg is. The hypotenuse is, but I do know the long leg is x. I do realize, by the way, that I could do Pythagorean theorem here to find this missing side, but if I don't have to do that, I'm not going to do that. So I want to keep going and see if I can still set up my proportion. On the big triangle, you know the short leg is 60. The hypotenuse would be the 36 and the x, so 36 plus x. Since I have a short leg of both of these and the hypotenuse of both of these, ignoring that middle guy, I can set up my proportion. I did the short leg over the hypotenuse. I cross multiply, making sure when I cross multiply, yeah, I'm doing 60 times 60, but I'm doing 36 times x plus 36 times 36. And now I'm solving. I subtract my 1,296 over, I divide by 36, and I get that x is 64. For all of these, make sure you draw your right triangles. If you have further questions on this, make sure you're asking your teacher.